Welcome to this video where I want to have a look at some common React questions I see quite a lot. Let's dive right into it. And by the way, this is just a collection of the questions that came into my head, that came to my mind. If you got more, if you got other things you see a lot, please share them in the video comments and I'll see what I can do in the future. So let's start. Let's start with one super popular question. Do I need a complex setup and workflow? For React, this can be really confusing because on the official page, if you use that quick start tutorial on React.js.org, you simply use some code in CodePen. So you drop in an import and you're ready to go. And still, thereafter, and in the majority of all courses and tutorials, you got more complex build workflows with Webpack, with a local dev server and all that fun stuff. So which setup do you actually need? It depends on which kind of app you're building. You can drop the React imports, React.js and React.dom.js, into your HTML files and start using React functionalities on these files. You can also use create React app, which is like a CLI for React, to get a feature-rich workflow with zero setup that still is 100% customizable because you can eject. Or you build your own workflow or use some boilerplate you find on GitHub. There you can of course tailor your workflow from scratch or build up on the existing boilerplate. Now the drop-in approach is great for multi-page applications, so where React should not manage the entire frontend, and for smaller projects. For bigger projects and single-page applications, I recommend using Create React App though. It gives you a really cool and optimized workflow and project setup that is still being worked on. Create React app is actively maintained. And therefore it gives you a lot of features you want to have in big apps, a lot of optimizations and so on. And a custom workflow could also be great for that, but you need to know what you do. So for highly specific requirements, that might be best because there you can build everything exactly as you want it to be right from the start. But in general, create React app with the option of ejecting and then customizing everything anyways seems like the best way to me, except for multi-page applications where you often work with drop-in imports. Here's another thing I see sometimes. Single curly braces versus double curly braces. If you're coming from Vue or Angular, you know that in your templates you output dynamic content between double curly braces. In React templates, you use single curly braces. The reason for this is simple. React doesn't use templates, it doesn't use HTML. It uses JSX, which behind the scenes is just JavaScript, just some enhanced version that looks like HTML. And since it's just JavaScript, you don't need a specific templating language which can be distinguished from normal HTML. You use single curly braces like you do in normal JavaScript anyways, for example, to create an object. This is a syntax then understood by React or transformed to normal JavaScript in the end, and therefore we have no specific templating language, we have no specific syntax for that. You can see the same for loops, by the way, where you use an array and map it to an array of JSX elements instead of using directives and stuff like that. It's really all coming down to the JavaScript-only nature of React. Speaking of the nature of React, there's another important thing. Functional versus class-based components. Which one should you use in which circumstances? So, functional components, also referred to as stateless components, receive props as an argument and return some JSX. This is what they do. They create a component with this minimum setup. They don't manage any internal state. State, of course, is an important concept in React, you know that, but it's not relevant for functional components. They don't have internal state. All the data they use are or is received via props. And you don't have lifecycle methods in there. You can't run through the lifecycle of the component in a stateless component. A class-based or stateful component, on the other hand, has a render method to return JSX and accesses props via this props. It also manages internal state, accessible via this state, and can change the state to re-render parts of the app, parts of the JSX code to the DOM. And it also can use lifecycle methods. So that's the core difference. When should you use which? Use stateless components whenever possible, which actually is in quite a lot of times. You can use stateless components a lot. Use stateful components whenever you need to manage state in a component. And mostly, you should use them as containers. So you have a couple of root containers, class-based components in the end, which manage state, which then pass down the state, and therefore, of course, also any state changes via props to a bunch of functional components. Why is this a good pattern? Because if you manage your state in a selected few components, then it's much easier to manage your app and maintain your app, because it's always clear only in places where the state can change. And if that's just a couple of components, that's much easier to manage. So therefore, try to keep the usage of class-based stateful components to a minimum. Another thing that's sometimes unclear is the set state syntaxes you can use. So this is set state. We can set a new state with it, and calling it will trigger React to re-render the DOM if there are changes at least. So this is set state, and one thing not everyone knows is that it runs asynchronously. So old state updates might not be reflected in the state immediately if you execute some code after set state. Often they are, but it's not guaranteed. It's asynchronous. There is a second version of set state, this one here, where you pass a function to set state, a function that receives the previous state and previous props. Now, the important difference to the first version is, in the first version we used this state inside of set state, and due to the asynchronous nature, we might be referring to an older this state than we expected. We're guaranteed to always get the last valid previous state, and if we then need some property from that old state, we now guaranteed got the latest version of it and use it to set the new state. Important, in that function, you return the same object you would have passed to set state in the first syntax anyways. Speaking of syntax, what does this map method do? You see that map method a lot in React apps, and it's basically used to output an array of items to the screen. So if you come from Angular, this would be your equivalent to the ng4 directive, kind of. Now, since we're not working with a template in React apps, but with just JavaScript code, we use just JavaScript features. And outputting an array of data onto the screen with this syntax does one thing essentially. It maps this array into a new array. So the goal is to output the JSX elements, or this data as JSX elements, I should say, and maps that into a new array. React is capable of outputting an array into the DOM, but that array needs to consist of JSX elements. So this is what we do with this map syntax. We just return a new array where every element of the array is based on elements in the old array, but of transformed elements. So we can transform that array with the syntax you see at the very top of the slide to this array, where we now have an array of JSX elements incorporating the old data. And this is really the whole idea behind map. We map an old array of just strings, numbers, whatever it is, into a new array of JSX elements that can be rendered to the real DOM. Styling React is another common source of issues. We get a lot of different styling approaches. Which one should you choose? Why is it so difficult? The first thing you'll learn in most tutorials is inline styles, i.e. you assign the styles directly on the JSX elements with the style prop. This works, but becomes cumbersome if you need media queries, it essentially doesn't work, or if you got more complex styles. Radium then is a package that could be a solution, so Google Radium to learn more about it. It essentially is a package that allows you to use media queries and more CSS-like features in your React app, because keep in mind with inline styles you're not really using CSS. Styled components is another package you could Google for. So these are all really package names, Radium and styled components. You can search for that too. It follows a different approach than Radium, but also with an approach or with the idea of giving you scoped styles. So styles that only apply to one component and giving you access to the full feature bandwidth of CSS. You could also use BEM, which is a CSS concept, which allows you to, or which is all about creating CSS class names that do the scoping. So if your issue is that you want to ensure that certain styles only apply to certain components, then you could create clearly defined class names in normal CSS, in a normal CSS file. No package is needed for that. And then use these CSS class names in your JSX code. And you can Google for BEM to find more information about it and how to structure these class names. The idea is to really create kind of components in CSS with normal CSS features, so without any package. If you don't want to create these long CSS class names on your own though, you can have a look at CSS modules, which is a feature you can unlock in Create React App, for example, if you Google for Create React App CSS modules. The idea behind it is that you create a normal CSS file still, but this package or this changed configuration in your workflow, as you do it for the Create React App setup, for example, will transform your short normal CSS names into unique ones on a per component level. So then each component will get its unique CSS class names, which you don't have to write, but which you get once compilation, once the build workflow is finished. So this is a nice approach, which I personally like a lot because it gives you really scoped styles without you having to worry about manually creating the appropriate CSS class names. And these are just some of the features, some of the possible solutions I can recommend that you Google, that you'll learn about to find the one you enjoy the most. Speaking of CSS, how can you use third-party CSS libraries? It's actually pretty simple. You can add a CDN link to index.html or a link in index.html to a local file, of course. Or you use a local file, and in most workflows, you can import that into your JavaScript files, even though it's a CSS file. But most React setups, like the one you get with Create React App, also support imports of CSS files, which behind the scenes will of course not be mixed with your JavaScript code, but will be kept separate. But your bundler, Webpack, is then aware of them and can process them. That's the idea behind the imports. So this is another common approach. You can of course also use npm or yarn to download, to install these packages if you're using Bootstrap, for example. But still, adding an import to your JavaScript files should work fine, and is the approach I recommend. It sounds strange, but it works in most workflows. And if you use Create React App, for example, it definitely works. What about third-party JavaScript libraries? How can you add these? Essentially, you get the same options. You can add script imports to CDN links or local files in index.html. And this is of course all referring to single page applications, but you can also import it like that in multi-page applications, of course. Or you import the local files into your JavaScript files, which of course works in a React app, especially when creating a single page application. You're importing JavaScript files from other files all the time. You're constantly writing import statements. And of course, you can import any third-party library into your JavaScript file, into your React JavaScript file as well. And you can start using the features of that library just like that. That should work fine. And of course, you can also use npm and yarn for that. This should also work. Let's go back to some core React functionalities and let's talk about immutability. That's something I see that can be hard to understand. So let me try to make it a bit easier. What is immutability about? We hear about it a lot when working with Redux, for example. And you can find an article with a lot of information on it in the video description actually. So the idea behind immutability is simple. Objects and arrays are reference types in JavaScript. Reference types mean that when we store an array in a new variable, and the same is true for objects, we don't actually create a copy of the value, but only of the pointer pointing to some point in memory. So the value still is the same, even if we store it in two different properties or variables. Therefore, to fix this, to get a real copy, which we can change without also altering the other one, which would happen by default, we have to manually clone. So really deeply copy any array or object we want to manipulate, and which we also want to copy. So how does this work? Well, here's the situation. Let's say we have an array, 1, 2, 3, and we're storing it in a new constant, new array. This does work, but what doesn't work, what I mean with that if we then would try to change new array, we would also change old array because of that reference type thing. So the solution is to instead clone the old array, for example with the slice method, which returns a brand new array object. So not a pointer to the same array, but a brand new one. If we then change cloned array, we don't also change old array. If you're using a setup which allows you to use next generation JavaScript features, you can also use the spread operator instead of the slice method. Now, for objects, it's pretty much the same. Here we get the same problem. We can't copy it like that. There we could use object assign to create a copy of an old object into a new object, or the spread operator for objects with this syntax you can see at the bottom of the box. Important, still what we're doing here is shallow cloning. So we're only copying or cloning the first level of properties of an object, for example. Let me show you what I mean with that. Here we have an object which also has an array, not just a name property, but also the hobbies property, which is an array of strings. If we now clone the old object with object assign, we do have a real new object with new properties that match the old properties, but the array hobbies also is a reference type, and it didn't clone that because it only cloned the first level, so only the property names, you could say. So therefore, if we now push something onto the hobbies array in the cloned object, we would actually still edit the array in the old object. The solution to that is to really manually clone all the levels we plan on changing. Doesn't hurt if we don't do it, if we don't plan on changing it, but if we do plan on changing something, we need to clone it. So here the cloned object would spread out the old object and then explicitly override the hobbies property by overwriting it with a new array where we also use the spread operator to clone the elements of the old object hobbies array. And now we get an object with a new hobbies array too. This is something to keep in mind. Again, there is a link with more information in the video description if you want to dive deeper. I hope it's a bit clearer now at least. Here's another thing I see a lot. Everyone can see my code. And it's true. Everyone can see your code. If you open the developer tools in your browser and you inspect a React app there, you can access the source files, the script files, and you can read the script code, of course. And there's nothing you can do. It's JavaScript, it runs on the client, so you can't hide your code. The solution is to not put any security relevant information in there. Don't put anything in there that you don't want others to see because you can't hide it, you can't prevent this. That is just how the web works in the end. Can I use React without Redux? Another question I see a lot. And the answer is yes, of course you can. React, by default, if you start a new React app, doesn't use Redux. It can be confusing for newcomers because the majority of tutorials is always React plus Redux. So is my course, by the way. Because it's such a popular combination. But in my course, for example, we start without Redux because it's not a must. You can use it. It becomes important for bigger apps. It makes managing the state much easier then, but it's not a must. And especially for smaller to medium-sized apps, there might be no need to use Redux. Another question I see a lot is if you can use React with PHP or the Laravel framework for that, or Node, or any other server-side language or framework. And the answer is yes. Let me show you how. It depends on whether you're building a single-page application or a multi-page application though. If you're building a single page application, then React controls the entire front end through that one single index.html file which was sent by the server. If you're building a multi-page application, then React controls only parts of the various pages your server sends you, the views the server sends you. React controls so-called widgets, so maybe an image carousel or maybe an accordion, something like that. Now for the single page application approach, we have the server which sends the index.html file, and that could also be a different server than the server where your business logic then runs on, by the way. Any static host does the trick. And then your React app, which runs in the index.html file, still can communicate with that or another server through a RESTful API. This is how that works. You communicate through a RESTful API. The server doesn't render views, you have that RESTful API instead. Now, if you're creating a multi-page application with React, then you also have a server which renders a couple of views, not just one. And whenever you interact with that views, you click a link or something like that, you send a new request to the server and you get back a new view. And React can be part of a couple or all of these views to control parts of these HTML pages. The widgets I already mentioned. This is how these two different approaches work, and it shows, of course, you can use React with any server-side language, by the way, because it only runs in the browser. It doesn't care about the language you're running on your server. It also doesn't care about any databases you might use there. Speaking of React running on the client, something I hear a lot is, my state is lost after page reloads. What can I do? It's true. If you're coming from a traditional web page world where you used sessions on the server to manage user state, like if the user is logged in, then this doesn't work for React. If you hit that refresh button, your JavaScript code runs again, and since it's detached from the server, there is no session management. There is no session. Now you got two alternative approaches for managing state. One is local storage and one is using a database on the server. Important, with neither of the two approaches, you're going to use a classical traditional session. Unless you're using a multi-page, building a multi-page app. So this is all referring to single page apps, I should say. So local storage is a client-side storage sitting in the browser. It's accessed via JavaScript. And with not under your control, I mean that you can't access it from the server. And it's a simple key value store. It's great for storing a JSON web token, for example, a common authentication mechanism in React single page applications, which allows you to kind of rebuild a session-like experience because you can, when your app starts, check whether that token already is stored in the storage and you can pick up that state. And that's not just true for the token. You can, of course, store any information in local storage that you want to check for on the next app start and that you want to possibly initialize your app with. Now, a server-side database, of course, is, well, running on the server and therefore fully under your control. The user can't clear it, uninstall it, or anything like that, as he can do with the local storage. It's accessible only from the server, which improves security. And it, of course, can be any database you want, so you're not limited to a key value store here. It's, of course, the right solution for data that needs to be long persistent. So if you want to ensure that the data can't be erased by the user or by the operating system, if the operating system is running out of space, it might clear unnecessary data like the data in local storage of browsers. So any data that needs to persist should be stored on the server, therefore. Can you host your app on Heroku and so on? That's another question I get a lot. Now, the important thing is that we need to understand what a React app is in the end once it's done. It's just a bunch of build artifacts generated by our build workflow if we run our production build process. And this again refers to single page applications. If you're building a multi-page application, of course, if you're building it with PHP or Node or any language supported by Heroku, you just deploy it there. For single page applications though, we got these build artifacts, which is just the index.html file, some JavaScript files and some style files, for example. Now, all these are static files. There is no server-side code in there. The JavaScript file is not Node.js, but a JavaScript file for the browser. Hence, Heroku and so on might be overkill, because there you need to write an application with PHP, with Node.js or stuff like that, just to serve that index.html file and the other static files. So a better solution here is to use AWS S3, Firebase hosting, or some other static host. Simply Google for static web host to find some possible services you can use. These services are best for serving your React single page application because you have no server-side language. Why would you take the overhead of installing everything and setting up some dummy app that just serves some static files? Here's another common error. My routes don't work after deployment. So let's say you're the user and you're visiting a page on the server, mypage.com. Now on the server, you then return the index.html file where your React app runs and where you display content. Then you click somewhere in that app and you navigate to mypage.com/products. And since we have routing set up in our single page application, and this is referring to single page applications only what I'm saying here, since we have routes set up there, the React router parses that new URL and renders the right content. On the server, you have no routes set up. Because it's a single page application, all that logic lives in your client-side app, in the React app. Now, if you don't navigate around by clicking, where React in the end catches the click and doesn't send a real request, but just see what you wanted to do and re-render the page, if you instead hit refresh, you really send a new request to the server. Now the problem is, you will get back a 404 error because the server doesn't know the /products route. It only exists in your React routing setup. So to go around this problem, we need to set our server up in a special way. We need to ensure that we always return the index.html file, also in 404 error cases. This then allows React and its router to always take over and parse the incoming request and render the right page. And if you want to still render 404 pages for certain routes, you need to set this configuration up in the React single page application via the router there, not on the server. You always need to return the index.html file. And that was it. I hope you enjoyed it. You learned some new things, maybe got some answers to some questions you might have had about React. Definitely share any other questions in the video comments. I probably won't answer them there, but I will note them and I might do an additional video in the future. So all the best to you. I hope to see you again on Academind in the future. Bye.